Hi everyone and welcome to lesson 1. Let's get started. The first lesson is on Introduction to Advanced Data Structures. As we dive deep into this intensive course on advanced data structures, let's first ask ourselves the question of why do data structures matter? Data structures matter because of two key things. Firstly, they're the backbone of any efficient software systems, be it building a small scale application, a large scale application as a personal project or a hobby project, or to a real life large scale implementation. Data structures are what empower everything you do in a software system. And second is that they enable solutions to complex computational problems. You will be able to build on more and more complex solutions using efficient memory usages, faster look through times, and much more higher compute. Let's look at the applications of data structures and especially advanced data structures. The very first one is in search engines. They help with fast data retrieval. In social media, dynamic updates and personalized recommendations, something that all of us have been using in our daily lives, is all powered by strong advanced data structures. And gaming, wherein there is real time rendering and decision making. All of this happens with advanced data structures. Now let's look at the different types of data structures that are there. The very first one is linear data structures, and the second is non-linear data structures. Linear data structures are organized in a sequential manner. For example, arrays, linked lists, stacks, and queues. All of these are examples of linear data structures. The applications for case of arrays is database indexing, sorting. In case of stacks, undo or redo functionality in text editors. Talking about non-linear data structures, and this is going to be a key part of advanced data structures. So these are hierarchical or interconnected structures. For example, trees, graphs, heaps, all of these are examples of non-linear data structures. A few key applications of these. If we talk about graphs, network routing, social networks. In order to represent relationships between different nodes in a graph, um, has a lot of application in different use cases. Think of social networks. There are so many different relationships that can be there between two user identities. All of that can be represented well using graphs. In trees, file systems, and decision making, all of these are good applications of where the tree data structure is used. Now that we know a basic about what counts as linear data structure and what is nonlinear data structure and why advanced algorithms are so essential, let's look at how data structures play a key role in algorithms and in problem solving. So data structures are algorithm enablers. For example, think about sorting algorithms like quicksort. It uses stacks or arrays. So it helps you implement an algorithm and you're able to store elements of your algorithm very well using an data structure. In case of graph algorithms, think of priority queues, which is used in Dijikra's shortest path. All of these are graph algorithms, and the thing that powers any efficient algorithm is good data structures. Also, data structures help to enhance the problem-solving capabilities. You can have much more efficient searching with binary search trees, or you can have real-time applications like priority queues for event management. In both these cases, you're using data structures to make your solution to be more efficient. Let's look at the key takeaways. The first one is data structures are foundational to efficient algorithms. Understanding structure types is essential for practical applications. Complexity analysis guides performance evaluation. This brings us to the end of the first phase of our lesson 1. Stay tuned for lesson 1's second part about complexity analysis.